Okay, we're back to do some solving equations here. This really ought to be just some review, so we'll be moving through it fairly quickly, but it's something you've been doing for a few years. Shouldn't be a big deal. So all we're doing is we're really just solving equations that are really one-step equations this go around, and equations that might look like this. X plus 7 equals 18. Now, for an equation like this, I know it's fairly simple, and I know that you can determine this answer just kind of by looking at it, but what I need you to do is to show your work. If you don't show work, you don't get credit, and I don't know what it is that you're thinking. There's going to be many problems in the future where you won't just magically know the answer, and therefore we need to know how we get to the answer. So it's the process that's important, it's not the answer. Nobody cares that the answer to this is x equals whatever. Okay? What we care about is how to get to that answer, the process to arrive there. So how do we get there? Well, what we have is we have a variable and we have this constant. Remember, the variable is usually a letter that represents a number. That number could be changing, as it was in the functions that we saw yesterday, or in this case it might be a specific unknown value. So in other words, this x really has only one value, we just don't know what it is right now. This constant term is, we call it a constant because we're adding 7, and 7 is always 7. There's nothing that's changing about that, and so that's a constant. So what we want to do is we want to isolate the variable, get the variable by itself, figure out what x equals. Well, so there's this plus 7 with an x. Well, I need to do something that will get rid of that plus 7, that will undo the plus 7. We call that inverse operations. So the inverse operation of adding 7 would be subtracting 7. And that's because plus 7 and minus 7, if you take positive 7 minus 7, you're going to get 0. And that leaves me with x plus 0, and as we know, x plus 0 is really just x. Okay? So on the left side of the equation, that's what we're going to end up with. Now, the one rule that you should remember from the last couple of years is whatever you do to one side of an equation, you have to do the same thing to the other because they're in balance. They have to stay balanced. If you subtract 7 from this side, then all of a sudden this one weighs much more. So to keep it balanced, you have to subtract 7 from this side, and then the things come back into balance. So we need to do the same thing here. If we subtracted 7 from the left side of the equal sign, we must subtract 7 from the right side of the equal sign. And here we see that 18 minus 7 is 11, so we know that x plus 0 equals 11, and so x equals 11. Now, I'm not going to be a stickler for this x plus 0 step. If you want to go right to x equals 11, that's fine with me, rather than writing at x plus 0. It works the same way with subtraction. If it were x minus 7, we would add 7 to get rid of that. That should be familiar. Let me move on to the multiplication and division. Again, these are one step, so it's going to be solved the same way. You're going to have something like 3x equals 18. Again, we all know the answer to this, but the point is do you know how to arrive at the answer logically, because we're going to have to apply these methods and processes later on in much more complex problems. So we look at the variable, we say what's happening to the variable. It's being multiplied by 3. What is the inverse operation of multiplying by 3? In other words, how do I get rid of that? How do I get x by itself? Well, I'm going to divide by 3, because that's the opposite of multiplying by 3. If I divided the left side by 3, then I need to divide the right side by 3. That again keeps it equal so that things are in balance. If I've divided both sides by 3, 3 divided by 3 is really 1. Right? Any number divided by itself is really 1. So this is really 1 times x equals 18 divided by 3 is 6. But 1 times x is simply x, because 1 times any number is that number. That's what we call the multiplicative identity, because when we multiply by it, it stayed the same. Just like when we added 0 previously, that's the additive identity. So here we've got our answer of x equals 7. We found the specific value of that. I do want to point out one kind of tricky problem that does come up in the homework, and it's actually a proportion. You may have seen problems that look like this in the past. In fact, I know you've seen problems that look like this in the past. And probably what you've heard is that to solve a problem like this is you should cross multiply and divide. Well, actually, it's a funny thing. The cross multiplication actually doesn't exist. There's no such thing as cross multiplication. It's simply a shortcut, a kind of a lazy way to do things, and it's usually easily remembered, but it's not actually mathematically accurate. So when you're cross multiplying, what you're really doing is you're multiplying by both denominators. Because if I multiply both sides by 12 and multiply both sides by 4, then what we're going to see is here my 4's end up canceling out. They actually become 1. They don't cancel out. They don't just disappear. They become 1. But I'm left with 12 times 3, which seems like we cross-multiplied to get 36. And here we've got x times 4, which is just 4x. And now we can solve this like normal, divide by 4, and we get x equals 9. That's probably how you've been taught to do this in the past. Notice that that's 2 steps. This quote-unquote cross-multiplying here, which doesn't really exist, and then you had to divide to get the variable by itself. What I think is it's much easier to just look at this problem exactly as it is. Instead of worrying about it as a proportion and having to solve it as such, just ask yourself the same question of what's happening to the variable and how to get rid of it. So just look, what's happening to x? It's being divided by 12. What's the inverse operation of dividing by 12? Multiplying by 12. So really, to solve this problem, you only need one step. You just need to multiply by 12. 12 times 3/4. And on this side, you've got 12 times by 12 and divide by 12, which becomes the 1. And 1 times x is simply x. And over here, we've got 12 times 3/4, which reduces to our 9. You can see that in a couple ways. You can remember that this is 12 over 1, and we multiply the fractions straight across, numerator times numerator, denominator times denominator, so you get 36 over 4, which is 9. Or you could realize that the 12 and the 4 will reduce. 12 divided by 4 is a 3, so 3 times 3 is 9. There are a couple of ways to simplify this using mental math, but you definitely shouldn't need to use a calculator for a simple calculation as this. But I did want to show you that it's a one-step problem, not necessarily a two-step as you've probably been taught in the past. So again, we're solving equations. We're just solving one-step equations. Remember, ask yourself, what's happening to the variable? What is the inverse operation? And apply that inverse operation to both sides, and then you simply write your solution. And please go ahead and do double check to make sure that everything works out. Does 3/4 actually equal 9/12? Yes, it does. So don't forget your double check step before you ask some questions, okay?